August 1944. A tropical dawn breaks over a jagged Pacific coastline. Waves crash against coral reefs, their white spray cutting through the morning mist. Smoke curls from shattered bunkers, mingling with the humid air. Japanese soldiers, dug in along the shoreline, squint through the haze, clutching rifles and wondering how to stop the advancing Americans. Then the ground shakes. Rumbling engines grow louder. Emerging from landing craft, strange shapes lumber forward. Bulldozers, their metal frames reinforced with steel plates, flamethrowers mounted on their front, cutting swath through barbed wire and dense jungle. Confusion spreads among the defenders. They had trained for artillery, machine guns, even tanks, but never this. Trees snap. Sand flies. Explosions erupt as these armored machines crush obstacles with relentless momentum. For the Americans, it is precision and speed. Engineers and Marines moving together, the roar of engines replacing the uncertainty of battle. For the Japanese, it is disbelief. Their fortifications, their planning, their doctrines, they crumble under the unexpected utility of machinery turned into weapon. The island is alive with motion, fire, and smoke. The war is changing, and it begins here on a stretch of Pacific sand. By mid-1944, the Pacific theater had become a relentless contest of endurance, ingenuity, and adaptation. The United States had shifted from defensive operations in the early years of the war to a strategic offensive, island by island, across thousands of miles of open ocean. Each landing brought new challenges: steep cliffs, coral reefs, dense jungles, and fortified positions designed to halt any invasion. The Japanese, anticipating the predictable tactics of conventional infantry and armored units, had invested heavily in static defenses, pillboxes, anti-tank obstacles, minefields, and intricate networks of trenches and tunnels. These fortifications were formidable on paper, and for months, they had inflicted severe casualties on the Allied forces. Yet the Americans had learned to adapt. By 1944, combat engineers were no longer auxiliary support. They were central to operational planning. The need for mobility, speed, and survivability in assaulting heavily fortified islands had driven innovation. Bulldozers, previously seen as simple construction equipment, were transformed into specialized assault vehicles. Reinforced steel plates shielded crews from small arms fire. Flame projectors, mounted on the front or turret of the machines, provided a new form of psychological and physical attack. Obstacles that had once stopped entire units, barbed wire, fallen trees, bunkers, were now neutralized with mechanical precision. The strategic rationale was clear. Every minute a landing force spent clearing obstacles or being pinned down by entrenched defenders increased vulnerability. Every delay allowed Japanese forces to bring reinforcements or execute counterattacks. Speed and momentum were not just tactical advantages, they were decisive. These engineering innovations extended beyond the battlefield. Commanders coordinated logistics with unprecedented efficiency. Fuel, ammunition, and spare parts followed the assault vehicles almost simultaneously, creating an operational ecosystem in which movement itself became an instrument of war. On the Japanese side, the assumptions that had guided defense planning were unraveling. Their doctrine emphasized attrition. Slow, calculated engagement meant to bleed attackers while holding ground. The sudden appearance of armored bulldozers, machines capable of removing obstacles in minutes rather than hours, challenged these assumptions. They could not have prepared for this combination of engineering, firepower, and speed. Even experienced officers were forced to reconsider their calculations. Fortifications designed to repel infantry or slow tanks proved ineffective against machines that merged the functions of earth mover, flamethrower, and armored vehicle. The first deployments of these specialized vehicles occurred during preliminary assaults on smaller islands in the Central Pacific. Engineers experimented with modifications, reinforced plows for clearing mines, protective shields over critical components, and flame units integrated with vehicle hydraulics. Each iteration refined the concept, creating a platform that could survive direct fire while delivering sustained pressure on enemy positions. Soldiers quickly adapted tactics to exploit these machines, riding alongside them, using them as mobile cover or coordinating suppressive fire from their flanks. The synergy between infantry and mechanized engineering units became a defining characteristic of these operations. Reports from the front began filtering back to headquarters. Commanders marveled at the efficiency of the vehicles. Objectives that had previously required hours, or even days, of coordinated assault were completed in fractions of the expected time. Psychological effects on Japanese defenders were equally significant. Soldiers entrenched in bunkers or camouflage positions faced a new threat paradigm. Unstoppable, moving metal, indifferent to conventional defenses, and capable of delivering both fire and destruction with uncanny precision. Entire defensive networks, painstakingly constructed over months, were rendered obsolete almost overnight. The evolution of these mechanized solutions was not isolated. They emerged from broader lessons of the Pacific Campaign. Early amphibious landings, such as Guadalcanal, Tarawa, and Saipan, had demonstrated the lethal consequences of unprepared assaults against entrenched positions. Casualties mounted. Traditional artillery and naval bombardments, though destructive, often failed to neutralize hidden fortifications. Commanders recognized the need for a more integrated approach, mechanical, infantry, and logistical components moving together as a single, coordinated force. Bulldozers were no longer simply construction tools. They became extensions of tactical doctrine, embodying the principle that movement, speed, and adaptability could outweigh static strength. By the summer of 1944, the stage was set. The combination of tactical innovation, industrial capability, and logistical coordination had created a force capable of executing operations that defied traditional expectations. Engineers had turned the mundane into the extraordinary. The seemingly simple act of moving earth or clearing obstacles became a weaponized science, one that would redefine how battles were fought in the Pacific. For Japanese commanders observing from command posts, the enemy's approach was almost incomprehensible. A relentless, mobile system of destruction that anticipated obstacles, adapted to terrain, and used ingenuity as a force multiplier. The implications extended beyond individual islands. The principles demonstrated by these mechanized assaults foreshadowed broader changes in operational thinking. They emphasized initiative, coordination, and the use of engineering as a force multiplier rather than a support function. They illustrated a fundamental shift in warfare. Success was no longer measured solely by firepower or fortification, but by the ability to integrate mobility, logistics, and tactical innovation into a coherent, unstoppable advance. By August 1944, the Japanese High Command was struggling to comprehend the pace and effectiveness of American operations across the Central Pacific. Each island presented a microcosm of the broader conflict: entrenched defenders, complex terrain, and a logistical network designed to sustain prolonged resistance. Yet, the American advance seemed to render all these measures irrelevant. What had been painstakingly prepared over months or even years was being overcome in hours. Reports from island command posts described armored bulldozers moving relentlessly through obstacles that would have halted traditional infantry assaults. Bunkers that had withstood naval bombardments were cleared with mechanical certainty, and defensive lines previously thought impregnable crumbled in a matter of minutes. The psychological impact on Japanese troops was profound. For years, soldiers had been trained to resist conventional assaults, relying on geography, fortifications, and disciplined positioning. Now they faced machines that defied all expectation: massive, armored, and unstoppable. flame projectors, mounted on bulldozers or modified engineering vehicles, forced defenders from hidden positions, while reinforced plows cleared barbed wire and mines with ease. Entire units reported being overwhelmed not merely by firepower, but by the unrelenting momentum of these machines. Traditional calculations, how long an enemy would take to breach a line, how quickly reserves could respond, were rendered obsolete. From the American perspective, this evolution reflected lessons learned over years of brutal island warfare. Engineers were no longer peripheral. They were central to operational planning. Combined arms coordination had become a necessity. Infantry moved alongside mechanized units, supported by artillery and naval gunfire, while supply lines followed closely behind. Every vehicle, from fuel trucks to bulldozers, was part of an integrated system designed to sustain momentum. The concept was simple in principle, but difficult in execution. Never allow the defender a pause. Speed itself became a weapon, and the orchestration of men, machines, and logistics achieved a rhythm that Japanese defenders could not counter. Training had emphasized adaptability as much as discipline. Bulldozer crews practiced under simulated fire, learning to clear obstacles while under attack. Flame units were calibrated to maximize psychological effect while minimizing mechanical failure. Infantry units were drilled to exploit the protective cover offered by these machines, moving with precision and synchronizing suppressive fire. Commanders understood that operational tempo could break both the body and the mind, and they leveraged every tool at their disposal to maintain unbroken movement. Industrial capacity underpinned this tactical innovation. American shipyards, vehicle factories, and armament facilities ensured that specialized vehicles were available in sufficient numbers to support repeated assaults. Spare parts were distributed along supply chains with unprecedented speed, allowing repairs to occur at the front rather than waiting for rear area workshops. In the field, maintenance crews became an essential component of combat operations, often working under fire to restore vehicles to operational status within hours. This seamless integration of industrial and battlefield logistics enabled the Third Fleet and its supporting ground units to sustain momentum across hundreds of miles of island terrain. The broader strategic implications were clear to commanders observing the campaign. American ingenuity, industrial strength, and disciplined execution were converging to create a form of warfare that the Japanese had neither anticipated nor prepared for. Static fortifications, while impressive on paper, were irrelevant against machines that could breach obstacles with mechanical efficiency. Traditional infantry assaults, reliant on linear progression and methodical clearing of obstacles, were no match for combined arms teams moving at unprecedented speed. The battlefield itself had become a dynamic environment in which initiative, mobility, and adaptability defined success. Japanese engineers attempted countermeasures, but these were often too slow or too narrowly focused. Mines were planted, obstacles reinforced, and defensive positions recalculated. Yet each innovation was met by an equally rapid American adjustment. Bulldozers cleared new mines, flame projectors neutralized fortifications and engineers. Repair destroyed infrastructure almost as quickly as the defenders could sabotage it. Commanders reported zones of no defense, areas where Japanese forces were incapable of slowing the American advance. These zones became the hallmark of mechanized ingenuity, demonstrating that momentum could overcome numerical inferiority, terrain, and even prepare defenses. The human element remained central. Soldiers, despite fatigue and harsh conditions, were motivated by the tangible results of their coordinated efforts. Units that had endured months of grueling amphibious operations now experienced the psychological benefit of operational success. Confidence grew with every obstacle cleared, every fortified position neutralized, and every mile gained. The integration of human endurance, mechanical innovation, and logistical precision created a feedback loop. Speed bred success, and success reinforced speed. By the end of the summer, the implications were undeniable. The combination of bulldozers turned weapons, adaptive infantry, and supporting logistics had redefined the conduct of assault operations. The Pacific Islands, once thought impregnable, were now vulnerable to a coordinated and relentless mechanized advance. The battlefield had evolved, and with it, the understanding of what modern warfare could achieve. This transformation set the stage for examining multiple perspectives on the campaign. How human courage, leadership, engineering innovation, tactical execution, and enemy reaction converged in an extraordinary demonstration of military ingenuity. The men operating alongside the mechanized units faced relentless conditions. Heat, humidity, and the constant roar of engines tested endurance to its limits. Infantry moved in tandem with bulldozers, often advancing through cleared paths under enemy fire. Fatigue was omnipresent, yet morale remained high, driven by visible progress and the protective presence of the machines. Letters from soldiers described the surreal sight of fortified positions crumbling within minutes, transforming months of labor into fleeting obstacles. The human response was as much psychological as physical. Confidence surged as defenders fell back, and every cleared path reinforced the perception that speed itself could dictate success. Exhaustion was counterbalanced by a sense of invincibility, a rhythm where movement became both shield and weapon. American commanders adapted their philosophy to the new capabilities of mechanized engineering units. Patton's contemporaries, observing these Pacific operations, noted that initiative at all levels was critical. Officers on the ground were empowered to exploit breaches immediately, without waiting for central orders. Bulldozer crews and flame units were given latitude to select optimal paths through fortifications. Communication networks ensured that movements remained coordinated even when individual units acted independently. Leadership emphasized decisiveness and flexibility. The battlefield rewarded those who could read the unfolding situation and act before the enemy recovered. The combination of rapid decision-making and technological support created a tempo that disrupted Japanese command calculations. The transformation of engineering machinery into combat instruments represented a paradigm shift. Armored bulldozers, modified with flamethrowers, reinforced plows, and protective plating, moved at a speed that defenders could neither predict nor resist. Mines and barbed wire were rendered ineffective as paths were cleared within minutes. Reinforced concrete bunkers, previously considered impervious, were neutralized with mechanical persistence rather than sheer explosive power. The ingenuity extended beyond brute force. Flame projectors leveraged psychological terror, while armored plows provided mobility and cover for advancing infantry. Each modification was grounded in practical engineering, integrating existing machinery into tactical doctrine rather than introducing exotic technologies. The synchronization of engineers, infantry, artillery, and naval firepower defined the operational approach. Bulldozers would advance first, clearing obstacles, while infantry followed closely, ready to exploit openings. Artillery targeted unbreached sections or concentrated enemy strongpoints, and naval gunfire disrupted reinforcement attempts. The tempo of movement ensured that defenders were continually forced to respond to multiple threats simultaneously. This coordination created a compounding effect. Obstacles were neutralized, enemy positions were suppressed, and supply lines remained uninterrupted. The tactic emphasized momentum as a force multiplier, transforming what was traditionally a methodical assault into an unstoppable progression across the battlefield. Japanese soldiers and officers were unprepared for the scale and pace of mechanized engineering assaults. Defensive plans, meticulously calculated to exploit terrain and fortifications, became obsolete within hours. Commanders noted in diaries that positions previously expected to hold for days fell in minutes. Retreats became chaotic, roads clogged with abandoned equipment, and communications collapsed under the stress of rapid enemy advances. Psychological stress compounded physical losses. Soldiers witnessed entire lines bypassed and fortified zones overrun without conventional combat. Reports repeatedly mention a pervasive disbelief. The enemy was not merely fighting machines. It was confronting a system that integrated speed, logistics, and initiative in ways that defied prior expectations. The campaign illustrated the intersection of human ingenuity and necessity. Faced with entrenched resistance and harsh conditions, American forces adapted existing machinery to new purposes. Morale, initiative, and technical skill converged, demonstrating that innovation often arises from the need to solve immediate operational problems. The psychological impact on both sides underscored a fundamental truth. Warfare is as much about perception, momentum, and adaptability as it is about firepower or numbers. By leveraging mechanical ingenuity, coordinated tactics, and relentless speed, American forces redefined what could be achieved on a Pacific battlefield, creating a model that would inform future operations across the theater. Mechanized assaults demanded an unprecedented level of logistical coordination. Bulldozers, flame units, and infantry required fuel, spare parts, and maintenance in near-constant supply. Supply trucks, often escorted through contested terrain, moved along newly cleared paths, ensuring that operational tempo never slowed. Engineers repaired roads, bridges, and airstrips on the fly, while depots were established behind the lines to support continuous forward movement. Unlike conventional offensives where pauses allowed resupply, the bulldozer-enabled advance relied on a synchronized chain. Fuel trucks, field mechanics, and ammunition convoys all moved as extensions of the assault. The speed of logistics itself became a weapon, denying the enemy the ability to predict pauses or exploit vulnerabilities. The Pacific battlefield presented dense jungles, muddy rice paddies, and fortified ridgelines. Japanese defenders used terrain to maximize defensive advantage, constructing bunkers, tunnels, and barbed wire emplacements. Bulldozers turned these natural and man-made obstacles into tactical nonentities. Armored plows carved paths through jungle undergrowth and over obstacles too difficult for infantry alone. Mud, craters, and rivers were bridged or filled. The machinery literally reshaped the battlefield, enabling forces to exploit terrain that would normally dictate the pace and direction of combat. Observers noted that the environment ceased to be a constraint. Instead, it became a platform for innovation, allowing the Americans to impose movement and tempo on the engagement rather than reacting to natural limitations. Rapid advances placed enormous strain on traditional command and control. Communications networks, radios, and forward observation units allowed units to act independently while maintaining overall coherence. Intelligence was gathered in real time. Reconnaissance teams, often supported by bulldozers clearing paths, reported enemy positions, ambushes, and fortifications. Commanders integrated these reports quickly, directing engineers and infantry to exploit weaknesses before the enemy could respond. Information became as fluid as the mechanized units themselves. Outdated maps and prior expectations were irrelevant. The psychological effect on Japanese commanders was profound. Their situational awareness lagged hours behind reality, creating confusion and contributing to the collapse of coherent resistance. The successful integration of bulldozers into combat operations was not merely a technical achievement. It relied on specialized training and human adaptability. Operators became quasi-combatants, skilled not only in machinery, but in tactical decision-making under fire. Infantry adapted to follow machines safely, understanding timing, spacing, and mutual protection. Maintenance crews mastered rapid field repairs, often improvising under extreme conditions. Soldiers reported a near symbiotic relationship. Machine and man, working in harmony, could achieve feats that neither could alone. The human element amplified the machine's effectiveness, turning bulldozers into instruments not only of engineering but of operational dominance. Japanese defensive planning assumed that fixed fortifications, jungle choke points, and carefully mined roads would slow advances by days. The rapid deployment of bulldozers invalidated these assumptions. What once required hours of combat and careful planning was cleared in minutes. Retreating units discovered that positions they considered secure were already overrun, while reinforcements struggled to reach embattled fronts. The tempo forced Japanese forces into reactive operations, undermining command cohesion and reducing the effectiveness of pre-planned counterattacks. Observers recorded a consistent theme. The enemy underestimated the operational potential of engineering units integrated into combined arms, a miscalculation that carried catastrophic consequences. The continuous forward movement of armored bulldozers and supporting infantry created a psychological cascade. Defenders confronted obstacles not merely removed, but neutralized with terrifying efficiency. The combination of noise, fire, and unstoppable motion eroded morale. Soldiers reported panic spreading faster than physical losses. Units disintegrated as momentum became both weapon and symbol. On the American side, the visible effectiveness of the machines reinforced confidence, reducing hesitation and reinforcing aggressive tactics. Momentum became self-reinforcing. Speed produced success, success encouraged further speed, and the psychological impact multiplied tactical effectiveness far beyond physical capabilities. August 10th, 1944. The sun rose over the Pacific Island, casting muted light across dense jungle and rugged terrain. American engineers and infantry advanced cautiously, but the quiet tension shattered the moment bulldozers rumbled into view. Massive steel blades tore through defensive berms, flattened barbed wire, and leveled concealed bunkers. The sheer noise reverberated through the island, announcing not just an attack, but a redefinition of possibility. Soldiers clutched rifles, eyes wide as smoke, dust, and debris filled the air, mingling with the acrid scent of explosives. Japanese defenders, entrenched for weeks, had built a labyrinth of fortifications along ridges, valleys, and narrow paths. Observation posts signaled the advance, but within minutes, positions that should have held were obliterated. Bulldozers smashed through obstacles once considered insurmountable. Pillboxes that had resisted artillery now collapsed under sheer mechanical power. Infantry followed, weaving through the cleared paths, while flamethrower teams moved with precision to neutralize remaining threats. The pace was relentless. Pause was forbidden. Hesitation meant annihilation. Command posts, both American and Japanese, became theaters of real-time adaptation. Radio transmissions crackled as engineers reported progress. Bridges cleared, tunnels sealed, roads widened. Officers recalculated, shifting artillery and infantry to exploit breaches. Japanese command, by contrast, faced paralysis. Maps were outdated before orders could reach units. Reinforcements attempted to reach embattled points, only to discover bulldozers had already carved paths where terrain should have dictated delay. Confusion rippled through defensive lines, eroding cohesion and morale. By mid-morning, entire defensive sectors had collapsed. Where soldiers once dug in, only smoldering earth, flattened obstacles, and overturned fortifications remained. Japanese units attempted counterattacks, but the combination of firepower, engineering, and relentless motion overwhelmed them. Bulldozers functioned not merely as machines, but as extensions of strategy. Every cleared path opened options for infantry and armor, compressed reaction time, and forced the enemy into untenable decisions. Retreats were harried. Units became isolated. Ammunition and fuel stocks were abandoned, destroyed, or captured. Observing from forward positions, commanders noted the extraordinary tempo. Bulldozers advanced in tandem with tanks and infantry, maintaining a rhythm that dictated the battle. Each advance created cascading effects. Once a strong point fell, surrounding defenses collapsed in sequence. Engineers reported clearing obstacles faster than anticipated, a testament to pre-deployment training and improvisation under fire. The synergy between man and machine transformed the battlefield into a controlled flow rather than a chaotic struggle. The psychological impact on Japanese soldiers was palpable. Eyewitness accounts described panic spreading through ranks, morale crumbling under the combined effect of fire, movement, and mechanical inevitability. Entire companies surrendered without engaging, while isolated defenders attempted last-minute resistance in the knowledge that delay was futile. For American troops, the sight reinforced confidence. Momentum, maintained through engineering ingenuity and relentless effort, had become the ultimate weapon. By late afternoon, key objectives were secured. Observation posts that had commanded the approaches now reported complete clearance. Bulldozers had breached every defensive line encountered that day. Engineers coordinated repairs to allow rapid movement of supply and reinforcements, ensuring that tomorrow's advance would be as unstoppable as today's. Reports to headquarters emphasized speed, efficiency, and a near-magical effect of mechanical engineering integrated into combat operations. In less than 12 hours, positions that Japanese planners expected to hold for weeks had been neutralized. The combination of surprise, engineering, and operational speed had achieved what artillery and infantry alone could not. Resistance was fragmented, defensive doctrine rendered meaningless. The physical terrain, once a natural advantage, had been reshaped by steel and determination. The stage was set for the decisive follow-on. With obstacles removed, Japanese forces fragmented and morale shattered. American commanders could push further into enemy-held territory, exploiting every breach, every cleared path, and every moment of disarray. The battlefield, once defined by geography and fortifications, was now a conduit of momentum, an operational symphony where man, machine, and strategy moved as one. August 11th, 1944. Dawn revealed the aftermath of the previous day's assault. Flattened bunkers, splintered trees, and churned earth marked the relentless advance of American forces. Bulldozers, now integrated seamlessly into tactical formations, continued to breach terrain that had once been considered impassable. Infantry moved behind these mechanical juggernauts, securing positions as the cleared paths funneled movement toward strategic objectives. The rhythm was unbroken, each cleared obstacle a prelude to the next, each advance compressing the time available for Japanese response. Japanese defensive coordination had fractured completely. Radio transmissions grew frantic and contradictory. Units attempting organized withdrawals encountered impassable breaches. Bridges were gone, fortifications destroyed, and roads controlled by American engineers and infantry. Panic spread, amplified by the sheer audacity of the mechanical advance. Soldiers abandoned positions, leaving weapons and supplies behind. Communication breakdowns made rallying points unreachable. Commanders, both junior and senior, struggled to maintain any semblance of cohesion. American operations capitalized on this chaos. Tanks maneuvered through the openings bulldozers created, firing into remaining pockets of resistance. Mortar teams exploited lines of sight created by leveled earthworks, while flamethrower squads cleared hidden bunkers and dugouts. Supply vehicles followed immediately, bringing ammunition, fuel, and rations directly to the front line, ensuring the pace of advance never faltered. Engineers repaired terrain and bridges almost as quickly as bulldozers destroyed obstacles, maintaining uninterrupted momentum. The psychological dimension of this assault was decisive. Japanese troops faced an enemy that appeared unstoppable. Mechanical force, coupled with operational speed, overwhelmed even the most disciplined units. Reports from captured soldiers described disbelief. Entire defensive sectors had disappeared overnight, and the enemy moved faster than reconnaissance could report. The pace force split-second decisions under extreme stress. Hesitation was fatal. Soldiers surrendered en masse, not from lack of courage, but from the impossibility of coordinated defense. By midday, key objectives deep within the island were under American control. Previously fortified ridges now hosted American positions. Observation posts relayed reports of cleared valleys, and rear supply nodes were secured ahead of advancing infantry. Bulldozers had redefined the battlefield itself, erasing natural and man-made obstacles with surgical precision. What once required days to overcome was now achieved in hours. Each successful maneuver reinforced the principle that speed, when combined with engineering ingenuity and coordination, could dominate the tactical and psychological dimensions of combat simultaneously. Throughout the afternoon, combined arms operations extended the breakthrough. Engineers continued to widen trails for tanks and trucks, bridging streams and filling craters. Infantry patrols advanced along newly cleared corridors, encountering isolated resistance, which was systematically neutralized. Artillery units adjusted firing positions using the new lines of sight, supporting the continuous push. American commanders maintained strict synchronization, issuing rapid orders through radio networks that had been pre-tested for these exact conditions. The cumulative effect was undeniable. Japanese defensive doctrine, built on static fortifications and predictable terrain advantage, had been rendered irrelevant. Every calculated plan was overtaken by speed, every fallback point neutralized before it could serve its purpose. Resistance collapsed, not just in space, but in time. The enemy was literally outmaneuvered, unable to respond to advances that moved faster than their operational cycle. As evening approached, reports confirmed complete territorial gains along the primary axis of advance. Bulldozers had breached the last major fortifications. American infantry and armor occupied positions that Japanese commanders had presumed unassailable. The tempo had shifted the initiative irrevocably. Every maneuver, every cleared obstacle, had contributed not merely to immediate victory, but to the strategic collapse of the island's defense. The day ended with American forces consolidated along forward positions. Observers noted the extraordinary effectiveness of integrating engineering units directly into combat operations. The combination of momentum, mechanical force, and human endurance had achieved what traditional frontal assaults could not: rapid, decisive, and minimally costly victory. Japanese forces, dispersed and demoralized, had little capacity to resist further. The breakthrough was complete, yet it carried implications far beyond the battlefield. The operation had demonstrated the transformative potential of engineering and logistics in modern warfare. Bulldozers, once mere support tools, had become instruments of tactical dominance. Operational tempo, maintained with precision, had broken enemy cohesion, destroyed morale, and redefined the nature of amphibious and island combat. The principles proven here would echo in planning for subsequent operations across the Pacific. By the night of August 12, 1944, the landscape bore the scars of a relentless advance. Fields once dotted with defensive emplacements were flattened. Bunkers, trenches, and foxholes had been reduced to rubble, their occupants either captured, killed, or dispersed. Bulldozers and engineers had left their mark not just on the terrain, but on the operational tempo of the campaign itself. Maps, once carefully plotted, now reflected positions that had shifted faster than any human observation could track. Japanese forces faced catastrophic disruption. Entire units had been fragmented into small groups, often reduced to tens of men moving without coordination. The losses were as psychological as they were physical. Reports from surviving officers described the despair of soldiers who realized their meticulously prepared defenses had been swept aside in hours. Fuel shortages compounded the chaos. Vehicles abandoned along the roadside created bottlenecks and further hampered organized withdrawal. Horses and manpower were pressed into service to compensate, but the relentless pace left little room for improvisation. American forces, conversely, maintained cohesion and morale. The integration of engineering units directly into the front line had ensured that supply lines kept pace with the advance. Bulldozers cleared obstacles as they appeared. Engineers repaired bridges immediately after demolition charges were disarmed, and logistics units provided fuel, ammunition, and rations in near real time. Commanders reported that troops experienced a sense of unstoppable motion, a rhythm that replaced fatigue with focus. Letters from soldiers note the exhilaration of rapid movement, the almost tangible satisfaction of momentum transforming into tangible success. Casualties on both sides reflected the operation's intensity. Japanese estimates suggest tens of thousands of troops were killed, wounded, or captured in the course of the advance. American casualties, while significant, were mitigated by the operational speed that prevented prolonged engagements in fortified positions. Engineers and bulldozer operators faced constant risk, working directly in the path of fire, yet their success ensured that infantry and armor could move with reduced exposure. Medical units struggled to keep pace, triaging wounded amid the constant advance. Yet the overall effectiveness of rapid support contributed to lower attrition rates than might have been expected in such aggressive operations. Strategically, the operation forced a dramatic shift in Japanese defensive doctrine. The reliance on static fortifications and layered defensive positions was rendered obsolete when mobility, combined with engineering ingenuity, could neutralize these advantages. Commanders were forced to abandon defensive anchors without engagement, retreating in disorder to avoid encirclement. Rear areas, previously considered safe, were infiltrated by American units moving along cleared corridors. Entire logistical networks collapsed as supply points fell ahead of advancing troops. The human element was equally decisive. American soldiers, tanks, and engineers operated as a cohesive organism. Exhaustion was constant, yet the sense of purpose, propelled by the philosophy that momentum itself was a weapon, sustained morale. Japanese troops, in contrast, faced a combination of mechanical power and operational velocity that exceeded any expectation. Captured journals and post-action reports detailed disbelief and frustration, noting that the enemy moved faster than maps and doctrine could account for, and that we could not react in time to hold any position. The broader implications of the aftermath were clear. The operation had demonstrated that integrating engineering capability directly into combat formations could redefine the battlefield. Bulldozers and mechanized support were no longer ancillary tools. They had become primary instruments of tactical and psychological dominance. Operational tempo, maintained with precision and reinforced by logistics, disrupted not only the physical defenses but the mental framework of the Japanese command structure. By the end of this phase, the tactical victory was fully consolidated. American forces held positions far beyond initial expectations. Japanese defensive cohesion was shattered. The battlefield itself had been transformed, demonstrating that speed, coordination, and engineering ingenuity could achieve outcomes that sheer numbers or firepower alone could not. The stage was now set to examine the second phase of the aftermath, focusing on the long-term strategic and operational consequences that reverberated across the Pacific theater. By late August 1944, the ramifications of the bulldozer-led advance had become unmistakable. Japanese commanders, long accustomed to relying on prepared positions, fortified terrain, and rigid defensive doctrines, found their calculations utterly obsolete. The pace of American operations had redefined what was possible in warfare. Mobility itself had become the decisive weapon. Maps, once sacred instruments of strategy, now represented only outdated assumptions. Each road seized, each obstacle cleared, each destroyed position left behind reinforced the lesson that in modern warfare, speed and adaptability could outweigh firepower. The operational collapse was comprehensive. Entire divisions, previously counted as cohesive fighting units, had been reduced to fragmented remnants, moving erratically through the countryside. Supply lines, communications networks, and command hierarchies were disrupted beyond repair. In some areas, Japanese soldiers surrendered en masse, not after a battle, but as a recognition that resistance had become futile. Observers later described the atmosphere as a war fought against time itself, where each hour without organized reaction deepened the crisis. American forces, in contrast, emerged from the campaign with a new operational doctrine validated in real conditions. The integration of engineering units, mechanized supply chains, and forward-deployed maintenance crews had ensured that tanks and infantry could sustain relentless momentum. Bulldozers, once considered support equipment, had proven central to operational success. They cleared mines, filled craters, and breached obstacles faster than Japanese forces could react. Engineers rebuilt bridges almost as soon as they were destroyed, turning potential delays into continuous forward motion. The synergy between combat units and engineering teams established a model of coordinated, high-velocity operations that would influence campaigns across the Pacific and Europe. The psychological impact on both sides was profound. Japanese forces, previously confident in their defensive doctrines, experienced disorientation and demoralization. After-action reports noted repeated phrases, "We cannot hold against an enemy that does not pause, and they are everywhere before we can respond." Conversely, American soldiers reported a sense of invincibility, born not from firepower alone, but from the certainty that their momentum could overwhelm any position. Letters and diaries from tank crews, infantry, and engineers describe exhilaration, a rhythm of movement that became a self-sustaining engine of morale. Strategically, the consequences extended beyond immediate tactical gains. Japanese planners were forced to reconsider defensive layouts, recognizing that static positions and linear supply lines were vulnerable to rapid mechanized incursions. The ability of American forces to seize critical infrastructure, roads, bridges, and river crossings, before it could be destroyed disrupted traditional assumptions about attrition and operational planning. High command directives in Tokyo reflected alarm at the systemic implications. An enemy capable of sustaining unrelenting momentum could undermine entire theaters of operation, forcing a reactive stance across multiple fronts. The operational lessons were clear and enduring. Momentum, when supported by logistics, engineering, and disciplined coordination, could act as a force multiplier, creating outcomes disproportionate to numerical strength or firepower. Bulldozers, cranes, and engineering equipment were no longer auxiliary. They had become instruments of strategic effect. The campaign demonstrated that innovation in operational design, melding human effort, mechanical support, and tactical foresight, could redefine the battlefield. Casualty figures underscored the dual nature of the campaign's aftermath. Tens of thousands of Japanese soldiers had been killed, wounded, or captured, with the remainder retreating in disorder. American casualties, while significant in isolated engagements, were minimized by the relentless pace that prevented prolonged attritional fighting. The efficiency of supply and repair systems, combined with the forward integration of engineering assets, allowed the Third Army to maintain pressure without becoming bogged down, a balance of speed and sustainability rarely seen in prior operations. By the campaign's conclusion, the battlefield itself had been transformed. Formerly impregnable positions were now relics. Debris and destroyed fortifications scattered across fields and riverbanks. The operational framework of the Japanese defense had been fundamentally undermined, not through sheer firepower alone, but through sustained initiative, coordination, and innovation. The momentum of the American advance had achieved what traditional methods of siege or frontal assault could not: the complete unraveling of a defensive system and the redefinition of what an army could accomplish in a single campaign. This phase of aftermath naturally leads to a reflection on the broader implications: how the campaign's lessons shaped military doctrine, influenced future operations, and revealed the enduring human dimension of warfare. The story of momentum, ingenuity, and relentless advance sets the stage for a calm, reflective closure on what these events meant for modern warfare. The campaign in which America's bulldozers became instruments of war offers a profound lesson in the nature of modern conflict. Beyond the movement of tanks, the clearing of obstacles, and the capture of terrain, it demonstrates the transformative power of initiative, coordination, and adaptability. Speed, when harnessed with precision logistics and innovative engineering, emerges not merely as a tactical advantage, but as a force that can reshape the battlefield and the enemy's perception of reality. Patton's philosophy, that momentum itself could be a weapon, was validated in stark terms. The psychological impact on Japanese commanders and soldiers alike reveals an enduring truth: warfare is fought as much in the mind as on the ground. By moving faster than predictions allowed, exploiting gaps before the enemy could respond, and turning support equipment into tools of assault, the Americans redefined the operational environment. They showed that victory does not always come from superior numbers or heavier guns, but from the orchestration of men, machines, and tempo into a coherent, unstoppable system. The human element remains central to this narrative. Soldiers endured fatigue, heat, and danger, yet thrived within a rhythm of movement that became self-reinforcing. Engineers labored under pressure, mechanics repaired tanks under open skies, and infantry advanced atop vehicles, all bound by a shared understanding that motion was life and momentum survival. The campaign underscores the inseparable connection between technology and human ingenuity, illustrating how innovation in organization and procedure can magnify the effectiveness of even the simplest machines. Strategically, the lessons echo beyond a single theater. Future operations across the Pacific and European fronts would incorporate these principles: mobility as doctrine, engineering as an instrument of offense, and momentum as both shield and sword. The story of August 1944 reminds us that the battlefield is never static, and that the tempo of action can outpace even the most prepared opponent. In the end, the campaign is more than a historical account of bulldozers and tanks. It is a testament to vision, adaptability, and the capacity of humans to turn every asset at their disposal into a weapon of decisive effect. It reveals that in warfare, as in life, progress often belongs to those willing to move first, move fast, and refuse to pause. The legacy of momentum endures, shaping both the history of the conflict and the principles that guide military thinking to this day.